Welcome to the fifth Learning Mashroom Server lesson. This time we are going to talk about the deployment of Mashroom and what needs to be considered for production setup. And we will see how a Docker-based setup could look like. We start with some considerations. Session setup. The setup of Mashroom Server in our previous lessons used an in-memory session store, which is not suitable for production, with multiple instances. So we have to switch to another storage. Currently, Mashroom supports a file storage, Redis, and MongoDB. Authentication. For a public site, we could keep the simple security provider to protect the admin area, but we obviously would have to change the admin password. For an internal portal, we would typically switch to an external identity provider, such as Active Directory or some OpenID Connect compatible provider. Now, regarding the storage, which contains the site and page configuration and also the permissions. We could use a read-only store on production and just package it with the server. Or we use a shared volume or a MongoDB for storage. Both approaches have advantages and disadvantages. As for the read-only setup, changes to site, pages, and permissions can only be made by developers. The data folder would be under version control and deployed as static asset. The admin toolbar should be disabled in this case. This comes with the disadvantage that a deployment is required for every change to the configuration, but brings a very high performance since the storage is basically loaded into memory once. The read-write setup allows it to change the configuration live, and it can be done by any user with the administrator role. If you are going to use MongoDB, you should consider using the Redis-based memory cache to improve the performance. Reverse proxy. You should always use a reverse proxy for TLS termination. Mashroom Server could theoretically do that as well, but it adds some extra load. A reverse proxy can also be used for caching of static resources, and it allows it to only expose a subset of pages, which brings an extra security. To improve the performance even more, you could also consider using a CDN. Mashroom supports all CDNs that work like a transparent proxy, which forwards all requests to the actual server if a resource cannot be found. And now the possible deployment scenarios. Basically, you have two options. You could use a process manager like PM2 or StrongLoop and launch a Node.js cluster, or use a Docker-based deployment, for example on Kubernetes. In this lesson, I will show the second approach, but here are some hints if you want to use a process manager. You can basically keep the server configuration from lesson 4. The only change you need concerns the session configuration. To switch to a file-based session store, add the Mashroom Session Provider file store plugin and change the server configuration as shown. The second thing you need is to change the log4j configuration. Make sure a separate log file is created per worker instance. So replace the log config file by the one shown here. Optionally, you could install the Mashroom Monitoring PM2 exporter plugin, which exports custom metrics to PM2, such as HTTP request count and session count. And here at a glance what we need to change for a Docker-based deployment. We need to switch to JavaScript or TypeScript server config files to be able to process environment variables. We have to switch to a file or Redis-based session storage. We could either just copy the data folder into the Docker image, or we switch to a shared volume or a MongoDB. We could remove the file log appender because a log file in a container environment has little use. And we should also make the default log level configurable via environment variable. At the end of this lesson, we should have a setup like this. A bunch of Mashroom server instances with a local read-only storage, a Redis server to hold the session, an open LDAP server for authentication and authorization, and an Nginx server that acts as a reverse proxy. Please note that the reverse proxy will not only terminate the TLS, but also allows to translate the internal path /portal/web to /. I won't explain the observability setup, the green stuff, in detail because there are a lot of resources available online. Let's start. As usual, we start with the output from the previous lesson. First of all, we are going to update Mashroom to version 2.3 with improved TypeScript support. To support the example setup, we also need to add 3 additional plugins. Mashroom Security Provider LDAP, Mashroom Session Provider Redis, and Mashroom vhost path mapper. Since we want to keep the current configuration for local development, I'm going to add a new folder prod and copy the server config and log4j.s config into it. And we turn those config files into TypeScript, so we can set properties dynamically from environment variables. We also need the Mashroom JSON schemas module because it contains the type definitions. In Mashroom TS, we expect 6 different environment variables and use it to configure the 3 new plugins. Regarding the LDAP configuration, I use a test LDAP server here, initialized with data from Futurama characters. That's the reason for the weird base dn. Also, the LDAP provider plugin expects a group to role mapping file. Let's create it and assign the administrator role to the admin staff group. Let's say we create here a portal for Planet Express and only employees should be able to access. Also, only users with the administrator role should be able to open the admin UI. So open acl.json and add a rule for portal and one for Mashroom. Please note the double star, which matches everything that starts with portal. 1 star means 1 path segment and 2 multiple segments. Okay, back to the server config file. The Redis config should be self-explanatory. The path mapper middleware does the translation from the internal path to the one at the reverse proxy. In this case, if the user arrives via localhost 6060/, it will be mapped to /portal/web. We have to tell Mashroom now to use the new plugins. So add Mashroom LDAP Security Provider as provider in the Mashroom Security Services config and Mashroom Session Redis Provider as provider in the Mashroom Session Middleware config. To optimize the performance, we also changed the check external change period MS property in the Mashroom storage file provider to something higher, since the storage is read-only anyways. And last but not least, we disable the admin toolbar for the same reason. If you now run npm start, you will see errors from the new plugins because they are not properly configured in the local server configuration. To fix that, add them to the Ignore plugins list in the development config file mashroom.json. Now to the log4j.s configuration. To be able to ship our logs to Elastic or Loki, we need a JSON output. So we have to define a new layout, optionally with some extra data such as app name, client and peer browser, and use it with our log appenders. And now we need a Docker file. We use a multi-stage build. In the first stage, we just copy all the plugin packages and build them. In the second stage, we copy the configuration files and the output from the build step, and only install the npm modules required for production. Additionally, we need a docker ignore file to prevent the node modules from being copied into the first stage. The final step is to set up the whole system. In this case, I use Docker Compose, but typically you would use a Kubernetes cluster. The Docker Compose file contains 3 instances of Mashroom, all exposed to a different port, and we pass the required environment variables. Then we need a Redis, a test LDAP server, and an Nginx instance with config files. The Nginx instance additionally needs a volume for the static cache. Let's have a quick look at the Nginx configuration. Basically, we define a backend with 3 servers and just pass every request to that backend. Like this, Nginx will use round robin to evenly distribute all requests to the 3 servers. Additionally, we turn on SSL with a self-signed certificate, and we also need to set the correct host header so the virtual host mapping plugin works. Finally, we also enable caching of static resources here, but that's optional. I think we are ready for launch, so enter Docker Compose up. This will take some time because the Mashroom Server image needs to be built first. Open HTTPS localhost 6060, confirm that you want to proceed with a self-signed certificate, and enter Fry as username and password. Well, everything seems to work. If you check the network console, you can see that the static resources are indeed cached by the reverse proxy. The Xcache status is hit. Now, if we try to access the admin UI, we get a 404 because that path is not forwarded to the backend servers. We need to access one of the Mashroom nodes directly, for example on port 8080. As you can see, the user Fry is forbidden. If we try the same with the user Professor, which is in group admin staff, it works. If you check the log files, you can see they are in JSON format now and contain context information such as username and browser. As a bonus, we are going to set up an observability platform based on Grafana. Besides Grafana itself, we need Prometheus to gather metrics and Promptail and Loki to process our logs. In the Prometheus config, we just add the 3 Mashroom instances as target and add a service and a node label. In the Promptail config, we define 3 log files that need to be watched, and the Loki instance the logs should be pushed to. We also add additional labels from the JSON properties like level. We also have to add the necessary servers to the Docker Compose file. And in the Grafana config, we define Prometheus and Loki as data sources and also a nice dashboard. Let's launch it. Open localhost 3000 and enter admin and test as credentials. Check out the predefined Mashroom dashboard. You can see some important metrics and the error logs, but there aren't any for the moment. Just for fun, we turn off Redis and see what happens. After a while, the Redis connections will turn red and errors will appear in the log. As usual, the code for this lesson will be available in a public Git repository. I will add the link to the comments section. I will also add some useful references to demo repositories and articles.